Hello, this is some quick advice as we're headed down the home stretch of your TELAs. I'm recording this at home, which means you might hear a train or dogs or cats or something in the background. If so, we'll just take that as a useful intervention. Okay, this first slide I'm just going to call appropriate metaphor. If you read the center section there, which you can pause this and read it if you want, it has the heart is like a command center and station and soldier, so it kind of has this military aspect to it. The first thing I always do is test the metaphor. In other words, how well does the metaphor actually fit what it is you're trying to say? In this case, it seems pretty good in that there's this central location, things go out and they come back, just like in a command center, right? Things have to go out, there's reconnoitering and all that stuff, and then the soldiers or the scouts or whatever come back. I mean, that's the image I have in my head anyway. But one of the things you want to test on it, like why is this command center or station better than, say, a bus station or an airport, right? So think of that, or a university building, or something that, or an octopus for that matter, that has limbs that go out and come back, right? Obviously those are flawed in different ways, but you might want to just push on your own metaphor, especially if it's a big one like this, takes up a whole paragraph. Make sure that you push on that. In other words, you could use both. You could say the heart is like a bus station first, and then expose that as flawed, and then come back and say it's actually more like a command center or a station where soldiers are housed. A military center of some sort. So in improving the metaphor, you drag the reader along with you and have a much more complete explanation. The second thing, well, I already just said improve or add if needed. And here's the case where I see something at the end of this metaphor down here. Therefore, vascular resistance. See if I can do a little pointer thing. Yeah, therefore, vascular resistance can relate to the booby traps and other obstacles that those soldiers or blood cells go through while they're on their route. I think, isn't vascular resistance sort of constant? Whereas booby traps and mines and that kind of thing seem to be site-specific. So should you add to this metaphor or improve it in a way such that it gets this idea that the vascular resistance is more constant as opposed to booby traps? Or choose other obstacles, maybe shrubs or trees or a command center in the jungle. Something like that might work. Or you can say, relate to the constant booby traps. I don't know. You have to remain consistent to the science as well with the metaphor. Get as close as you can. My last point, is weave your language once you've got context. And what I mean by this is, right here it says that the soldiers or blood cells go through while they're en route. I think you can either get rid of soldiers here. The booby traps or other obstacles blood cells go through while they are on their route. Since you've already got the comparison set up and you've got good context, I understand the booby traps and obstacles are applied to blood cells as they go, while they're en route, as they travel through the arteries. Okay, that's the end of that slide. Slide 2 here is about a sentence out of place. So if you read this paragraph, you'll see that the second sentence really doesn't fit. I'm still here, I'm just letting you read. Okay, now you can redo this YouTube video if you want, but right here, this is good in the sense that it's trying to tie to the study, but it seems like it's dropped in the middle of computed tomography CT scans. Okay, now I know this is a draft, so, this kind of stuff happens all the time. You have something, or maybe there was a cut and paste job that wasn't complete. All kinds of things can happen at a draft stage. So, but the metaphor is pretty solid. Imagine slicing a watermelon, and with each slice you can see different textures. Okay, that sort of sits well with the first two sentences. So if we took that sentence out, but it does bring up a bigger issue. I did it again. It does bring up a bigger issue. and I put focus and connect. In other words, focus your paragraph on one idea or one process or one thing you're trying to get across, and then use the beginning of the next paragraph to connect stuff. So it's all about focusing and connecting with a TELA like this, where you've got a lot of information you'll be juggling. So imagine that this sentence sat after the current paragraph. So if we kind of start here reading, except CT scans do not slice the actual brain, instead it just takes pictures of slices of the brain. The next paragraph could start, these CT scans are particularly important for detecting symptoms that varied so widely with age in the study. There I'm connecting to this idea of age. Okay, it's kind of a sloppy transition, and that, actually it's a very sharp transition, but it may be sloppy logically depending on what this person wanted in the next paragraph. But that's just a way to like connect. And here's your topic position, right? And then here would be all this stuff in here would be the, oh God, I'm massacring that. All that stuff in there would be your stress. We talked about the topic and stress, so the old stuff and the new stuff. Okay, this third slide is all about cutting. So I'm just going to do it. Because these AGEs exist, it is possible for us to use skin autofluorescence to detect these AGEs. I'm thinking to say them instead of these AGEs. Autofluorescence, if you are not familiar with them, is the natural light that are emitted. I think you can just get rid of. Just go for it. The reader's following you already. Autofluorescence is the natural light that is emitted from microbiological structures such as mitochondria and lysosomes. Don't worry, for this paper you don't need to understand what a mitochondria or lysosome is. All you need to know is that they emit light. And I'm thinking, if I'm going to bring this up and then apologize for it being in the paper or tell the person don't worry about it, don't bother putting it in. So, if I need to explain mitochondria, I don't need to bring it in at all. And then the way it works is that the autofluorescence, I can just say, autofluorescence acts, oops, I'm trying to get rid of that can, as a marker and reflects the accumulated AGEs from your skin, period. Wow, I don't draw very well. To get a better idea of how it works, comma, try thinking about a crime scene where the forensic specialist will shine the areas with black light to look for evidence such as blood and various DNA. Here I would say, instead of try thinking about a crime scene, I would say try thinking about the black light. So skip to this first. Try thinking about a black light that forensic specialists used on a crime scene to look for evidence such as blood. I don't know about DNA. Do you see DNA with a black light? I don't know. Whoever's piece this is will have to check that. Being able to see the accumulation of AGs. Now here's a case where we really need to have some connecting, right? So I have to connect the metaphor, right? The analogy to the thing I'm actually trying to describe. So think of that last sentence, being able to see the accumulation of AGEs can give the doctors a better idea of how much at risk you are of having not only diabetes, but other conditions such as renal disease. Well, I was there with the forensic specialist inside the analogy, in that world. Now I got to come out to the science world of AGE and all that. So I could start another sentence. The next sentence would use something like, scientists use autofluorescence in much the same way, exposing AGEs, or highlighting AGEs, or illuminating IgEs. So similar to the previous slide, you can start weaving your language in once you've got the context. Okay, in this final slide, honestly, you can pause this or sign off on it because this is the last thing I'm going to say. This is about when you're finally looking at your draft at this stage. Would you rather start reading a piece that begins, Huntington's disease is a hereditary brain disorder that affects the human brain, causing an afflicted person to have a lower mental capacity, an increased risk for psychiatric problems, and impaired physical motor functions? You guys are scientists in training. You probably want that sentence. The loss of I'm down in the second paragraph, the loss of neurons in the brain is akin to the lifespan of a kitchen sink sponge. Well, I got to tell you, in that second paragraph, you got me. You had me at sponge. Okay. I think this is a case where that actually can be put first. Because even if someone doesn't quite know what neurons, I think a lot of people would, but even if they don't know what neurons are, they do see brain in there, and they understand lifespan of a sponge. And they understand what a sponge does. And then we get into Huntington's disease, and then you can have the technical definition more. Okay, I'm signing off. Thanks for listening.